and how they relate to exponential functions, or exponential equations in particular. And one thing we're going to need to know is this exponent property of logs, which I'm going to write a little bit larger down here. So this log base b of a to the r equals r times log base b of a. And basically what this is saying is that if we have something inside of a log that's being raised to a power, and it has to be everything inside the log being raised to the same power, okay, as we see here with the a to the r, then what we can do with that power, this r here, is move it to the front. Okay, so notice when we do that, we'd end up with r times log base b of a, which is what we have over here. Okay, so as an example of that, if we look at here, log base 6 of x squared. So if we use the logarithm property here, so we see that we have the x inside the log being raised to that second power. Can move that out to the front and then rewrite this as 2 times log base 6 of x. Okay. Now, why is that helpful? Well, it's going to be helpful for us when we go to solve equations, exponential equations. If we have something like, say, log of 4 to the x, we'll notice we can move the x down to the front, and then what we end up with is something like x times log of 4, and now we've got the x in a place where we can isolate it. Okay, so that's why this is useful for us. So we're going to get into solving some exponential equations, but before we do that, I just want to kind of go over a general approach to these problems, so kind of a way to go after or attack any of them. So the first step is to isolate the exponential expressions when possible. Once you've done that, then take the logarithm on both sides, and generally you'll be using the common log, so the log base 10 to do that, but sometimes you might use ln. Then you utilize that exponent property for logarithms to pull the variable out of the exponent, and then use algebra to solve for the variable. Okay, so let's look at what this looks like in practice. So we're going to return to this problem we started this section with, the 2 to the x equals 12. I'm going to write it larger over here. And first of all, notice in this equation that the exponential term, the 2 to the x, is already isolated, right? There's nothing over here on the left-hand side with it. So that first step that we were just looking at is already done. So next what we want to do then is take the log of both sides, and in this case we'll just use the common log, so I'm using log base 10 here. Which, doing that on the left hand side, now notice I have log of something raised to a power. So I can take this power here and move it out to the front. So this will become x times log base 2 equals log of 12. And I know when we look at this equation now, we see letters and numbers and words and all kinds of stuff flying around. But recall that log base 12, or sorry, log of 12 and log of 2, those are things that we can just plug in the calculator and get answers for, right? So they really just represent numbers. For now, we're not going to plug them in the calculator yet. We're going to leave them like this. And we're going to finish solving for x. So notice here on the left-hand side, I have x times something, okay, even though something's kind of large, which means I can solve for x by doing the opposite operation, which is divide by that something. Okay, so divide by log base 2 on both sides. And what we end up with is x equals log of 12 over log of 2. And we can take that now and plug it into the calculator. Okay? And we're going to be very careful about how we do this. So notice in what I had written there was log of 12 divided by log of 2. So we need to make sure that that's how we put it in the calculator. So I'm going to do log of 12. And then notice that it opened a parenthesis on the log, so I need to close it. So it's log of 12 divided by log of 2. And I'll close that parenthesis. Okay, so it looks something like that. Press enter, and we see that our answer is 3.585, which is really close to what we had kind of guesstimated, it being around 3.5. Okay. All right, let's go back to the PowerPoint and do the other problem. So now we have 5 times 1.3 to the x equals 10. Okay, and notice in this one now the exponential term, which is the 1.3 to the x, is not isolated, right? There's this 5 over here being attached to it. Now, do not multiply the 5 and the 1.3. Why can we not multiply the 5 and the 1.3? Well, that's because the 1.3 is being raised to a power, right? So we can't multiply those two. So we have to isolate the exponential term. And notice that we have 5 being multiplied by that exponential term, so it's 5 times 1.3 to the x. So to isolate the exponential term, we'll divide by 5 on both sides. So it'll cancel out the 5s on the left. So we have 1.3 to the x equals 10 divided by 5 gives us 2. And now that we have the exponential term isolated on the left, we can take the log of both sides. Okay, which will allow us then to move the x out to the front. So I have x times log of 1.3 equals log of 2. We again now divide by log of 1.3 on both sides, again because we're isolating the x on the left. Okay, so these will cancel, and it looks like we end up with x equals log of 2 divided by log of 1.3. We again go to our calculator now to plug that in. And again, notice on both of these problems, I didn't plug the logs in until the end. I suggest that that's how you all approach these as well. So go here, we're going to do log of 2 divided by log of 1.3. And here we end up with 2.642. Okay. All right, that's it for now. Thank you for watching.